Morning, my dear people, and welcome to chapter 4.4. This week we are only doing one section, 4.4, and a quiz. So, yeah, you got it. Okay, 4.4 is actually pretty short. It only has 2 learning targets. You see that? You need to be able to evaluate trigonometric functions of any angle, and then you need to be able to find reference angles and use reference angles to evaluate trigonometric functions. What in the world are we talking about? Here's what we're talking about. There is an old definition of the trigonometric ratios, which you've been using your entire life since you've been aware of it. And that old definition is basically SOHCAHTOA. SOHCAHTOA defines the sine, the cosine, and the tangent by using the sides of a right triangle and the hypotenuse, right? So this is your H, this is your A, and this is your O. However, trigonometry and trigonometric ratios can also be used to find angles that are more than 90 degrees. And you will notice that in a right triangle, there are no angles that are more than 90 degrees. So if I were to ask you to find the sine of, 265 degrees, you'd have a really hard time drawing that picture on a little right triangle, wouldn't you? Because trying to find an angle that's 265 degrees in a right triangle is not possible. So what we're going to do is we're going to amplify the definitions of sine, cosine, and tangent. And while we're at it, we're going to add the cosecant, secant, and cotangent to make it more general than just SOHCAHTOA. SOHCAHTOA is a good definition, and it works as long as we're dealing with angles that are 90 degrees or less. However, if we're dealing with angles that are more, we need something bigger. And here's what we have. We're going to say, definition. Let theta be any angle in standard position, and let the point P of x be a point on the terminal side of theta, other than the origin, of course. Let r be the distance from P to the origin. We define the sine of theta as y over r. Now, that is really weird and confusing looking, so we're going to do an example. We're going to unwrap that and make sure you know what we're talking about. So let's do an example. Example 1. Let the point 3, 4 be a point on the terminal side of theta. Find the sine, cosine, and tangent. All right, so what we're going to do is we're going to draw a picture of this. Let me give myself some room over here. I'm going to draw a picture, and this angle in particular is actually less than 90 degrees, but I'm starting with one less than 90 degrees because I'm starting with what is familiar to you, and then we're going to move to the unfamiliar in the next slide. So let's pick the point 3, 4. So 1, 2, 3, 1, 2, 3, 4. So here's the point 3, 4. And let's see what our definition says. So let P be a point on the terminal side of theta. So this is the terminal side of some angle. There you go. And this, of course, is therefore my angle theta. So it's telling us that we can define the sine as y over r. Now, r is the distance from the point to the origin. So if this piece here is 3, and this height, of course, is 4, because that's the point 3, 4, then you know, obviously, that r, or in other words, the hypotenuse, has to be 5. So what I can say in this particular case, I can say that the sine of theta equals y over r. Now, what's y over r? It's going to be 4 over 5. Okay? So really, what I'm saying is still SOHCAHTOA. I'm saying that the sine is the opposite over the hypotenuse, but I'm not using the words opposite and hypotenuse. I'm instead using the y-coordinate and the distance from the point to the origin. And I'm using that definition now because it's more broad and it allows us to find the measures for other angles that are more than 90. The cosine is defined as x over r. Now, r is 5, and the x value in this case is 3. And so therefore the cosine would be 3 over 5, which in this case, if you look at this triangle, it's just adjacent over hypotenuse. And of course, then the tangent is defined as y over r. And of course, x can't be 0, but you know why. So y over r. So what's the y? The y is the 4, the r is the 3. So in other words, it's the y-coordinate over the x-coordinate. In other words, it is the opposite over the adjacent. Okay? So these definitions, as you can see, they give us the same values that we would have gotten if we had just considered this a 3, 4, 5 right triangle, which it is. But now I'm going to give you another example in which these angles are going to be more than 90 degrees, and you'll see why we want to amplify the definition away from just SOHCAHTOA to the sine equals y over r. All right, so let's take a look at those examples now. So here's example number 2. Let the point negative 3, 4 be a point on a terminal side of theta. Find the sine, cosine, etc., etc., etc. All right, so again, I'm going to draw a little picture of it. You should always draw pictures for yourself until you get to the point that you're so good at visualizing this that you really don't need to, but we're not there yet. So negative 3, 4 is over here. 1, 2, 3, 1, 2, 3, 4. There's the point negative 3, 4. It's our point P, so to speak. And then, of course, I'm going to draw this angle. There's that angle right there. And my angle theta is this guy right here. He's theta. So as you can see, theta is 100 and some degrees, right? You're never going to find 100 and some degrees angle inside a right triangle. So SOHCAHTOA doesn't actually cut it anymore. And that is why we need to have these new definitions. Using these new definitions, though, it's going to be pretty simple. We're going to say that the sine of theta is y over r. All right. The y value is right here, and it's 4. And you can see that from the point, obviously. The x value is here, and it's negative 3. And of course, you can see that also from the coordinate point. The distance from that point to the origin, of course, is still 5. It's still a 3, 4, 5 triangle. And the distance from the origin to the point in question is always going to be a positive number, because when you use the Pythagorean theorem to find it, you're always going to get a positive number. The y or the x, they can be negative, depending on where the point is. So now the sine is going to be defined as y over r. So the sine is going to be 4/5. Now, if you try to think of SOHCAHTOA, it's a little bit harder to see that now, because SOHCAHTOA says opposite over adjacent. Opposite over hypotenuse. And we kind of have that. We have the opposite over the hypotenuse, the 4 over 5. But the angle we're talking about is this guy outside of the triangle. Okay? So now the cosine of theta is going to be defined as x over r, the x being negative 3/5. So the cosine, whenever you're in the second quadrant, is going to be a negative number. Try to punch in your calculator. Try to find the cosine of anything negative. Try to find a cosine like 120. You'll see it's negative. And lastly, the tangent of theta is going to equal y over x, which in this case is going to be 4 over negative 3. Okay? Or negative 4 over 3. That's the same thing. So those are the values. Over here, I have a little cheat sheet, and you should know that all students take calculus. Well, that may not be true, but all pre-calculus students should take calculus. What is this? It's a memory device. It's a mnemonic device. ASTC. In the first quadrant, all of the trigonometric ratios are going to be positive. All of them. In the second quadrant, only the sine is positive. And of course, his buddy, his reciprocal, the cosecant. In the third quadrant, only the t, or the tangent, is positive. And in the fourth quadrant, only the c, or the cosine, is going to be positive. And so a way to remember that is that all students take calculus. First quadrant, everybody. Second quadrant, only the sine. Third quadrant, only the tangent. Fourth quadrant, only the cosine is positive. And so let's see. This angle here was in the second quadrant. So who should be positive in the second quadrant? The sine, only the sine. Notice that the sine is positive, but the cosine and tangent are both negative. So that's one way you can remember and predict what it's going to be. All right, let's do one last one. Let me move my page up a little bit. And I haven't addressed the cosecant and the secant and the cotangent, but they're just reciprocals. I mean, it should be fairly obvious. If sine is y over r, then the cosecant is r over y. Nothing weird about that. Okay, so let's do one more. It says, now this is backwards. Given that the tangent of theta is negative 5 over 4, and the cosine is greater than 0, find the sine and find the secant. All right. Well, let's unravel this thing and see what it wants us to do. So I'm going to draw the picture first. And you always need to start with a picture. I've had a few students over the years that can just visualize this in their head. Those are weird kids. Most of us can't. I can't. So the tangent is going to be negative 5/4. And the cosine is greater than 0. The fact that the cosine is greater than 0 tells you something. So first of all, you know that the tangent is negative and the cosine is positive. You see that? The tangent's negative, 5/4, and the cosine is positive. So which quadrant must my angle be in if the tangent is negative but the cosine is positive? It can't be the first quadrant because they both be positive there. It can't be the second quadrant because they both be negative there. It can't be the third quadrant because only the tangent's positive there, so forget it. The fourth quadrant, it has to be in the fourth quadrant because that's where the tangent is negative and the cosine's positive. So I know that my angle goes down here. So it's going to be, let's see, negative 5/4. So 1, 2, 3, 4. 1, 2, 3, 4, 5. Now, some of you might be thinking of, well, I could tell it had to be there just by the points. Not really, because realize that negative 5/4 could also be written as 5/-4. So technically, it could have also been the point up here. You see, up 5 and backwards 4. But we know it's not him because it has to be in the fourth quadrant. All right, so now I'm going to go ahead and draw this angle. And the angle we're talking about is actually a really big one. It's like 300 degrees or something. It's this big beast right here. That's my angle theta. All right, so let's draw this little triangle. And I know that this is a distance of negative 5. This is a distance of 4. And once I have that, I don't need to do any calculations or computations. I just know that the sine of theta is going to be y/r. So I know that y is negative 5 because this is the point for negative 5. And the y distance is always the vertical distance. And then r, well, I don't actually know what r is, but I can figure it out easily. So I can just come up here and do 4 squared plus 5 squared equals c squared. And technically, it's 4 squared plus negative 5 squared. But negative 5 squared is a positive number, so I'm not going to bother. And I'm going to get that, it's the square root of 41. So that distance is the square root of 41. So I'm going to get that the sine of theta is negative 5/41. The square root of 41, or negative 5√41/41 if you rationalize the denominator. The secant of theta, well, let's see. The secant is right here. It's the inverse of the cosine, and that's r/x. So that's going to be the square root of 41 over the x value of our point, or the x distance, which is going to be 4. And therefore, it's going to be √41/4. Now, yeah, I'm going to stop right there at that. But I would just like to point out that you can verify these things in your calculator. We don't actually know what theta is, but if you were to find theta in your calculator by doing the inverse tangent of negative 5/4 and find out what the angle is, you would then be able to verify that the sine of that angle is in fact this value, and the secant of that angle is in fact this value. I'm not going to do that now, but you could verify it if you'd like to. Okay, so that is the first part of this lesson, and hopefully it's pretty easy. And it's a very important one because we're redefining the trigonometric ratios. We're not going to use SOHCAHTOA as a crutch anymore. We're going to kind of write them with a different definition. And these are those new definitions. Okay, I will see you in the next video.